Okay, so for this video, I'm going to show you what equivalent fractions are. Okay, first, the word equivalent. Equivalent means equal. Okay, in this case, we're going to be working with fractions that have equal amounts. Even though when the fraction is different, they show the same exact amount. Let me show you how that looks. Okay, so an example of an equivalent fraction could be, let's say I have a whole right here. I have this model right here, and this whole model is shaded, right? This whole model is shaded, so this means it's just one whole. Okay, so this one is equal to one whole, right? It's the complete whole shape shaded, so it's equal to one whole. If I get this same shape, this same model, and I divide it right here into two equal parts, now I have two shaded parts out of two shaded parts, right? So it will be equal to two shaded parts out of two equal parts. Okay, that means that one whole is equivalent to two halves. But there's even more. If I divide this shape again by another line right here, now I have four equal parts, right? I have 1, 2, 3, 4 equal parts. Now I not only have two, I have four now. So I still have the whole shape shaded, so that means now I have four parts shaded. So my fraction will be 4 parts shaded out of four equal parts, right? Because now I have four equal parts. That means that one whole, two halves, and 4 fourths are all of them equivalent fractions. They mean the same. When you put them in a model, they show the same exact area. So what happens when we do not have one whole? When we do not have the whole model shaded? So in this case, for example, in this shape right here, this model is showing the fraction 1/2, right? I have one part shaded out of two. I only have one, so it's 1/2. When you have something like this, like 1/2, an equivalent fraction to this could be this. So if I divide my model again in half, you notice the same area is shaded, but now my denominator changed it, right? It changed. So now instead of having only two equal parts, now I have four. That means that this 1/2, it's equal, and then I can create here my equivalent fraction by putting the new fraction that I'm showing in this model. Okay, this one is showing 2, it's showing 1, 2 parts shaded. So I'm going to put my numerator will be 2 this time because I have 2 parts shaded. And then I have 1, 2, 3, 4 equal parts. So that means my denominator is going to be 4. That means that 1/2 and 2 fourths are equivalent because they show the same exact area. But wait, there's more. There's more. I can still find another equivalent fraction using the same model and the same exact shaded area. So let's try and find the other one. Okay, let's try and find another equivalent fraction. Another fraction that means exactly the same. Let's see. So if I have this model right here divided in 4 equal parts, I can still divide it in more equal parts. If I drew a line right here, whoop, that one came out a little bit crooked. If I drew another line right here and then another one right here, I have equal parts, right? All of my parts look exactly the same area, or kind of, because my drawings are kind of weird. So let's try and figure it out this new fraction that we're going to make. Still with the same area shaded, we have a new equivalent fraction. Now I have how many pieces shaded? I have 1, 2, 3, 4 parts shaded. That means my numerator right here is going to be 4 because I have 4 shaded 4 4 shaded parts, and I have a total of 1, 2, 3, 4, 5, 6, 7, 8 parts. So my denominator is going to be 8. So that means that 1/2, 2/4, and 4/8 are equivalent fractions. All of them are showing the same exact shaded area.